Alright, area of triangles. You probably know that the formula is 1/2 base times height. So we're going to use that formula when you can find the base and the height of a triangle. I say that because there's another way we could find the area of a triangle when maybe we could only find the base and not the height. Real quick, just a quick explanation of why it's 1/2 base times height. You may notice that this base times height is a familiar part of a formula. That's the area of a trapezoid. So any trapezoid, I meant parallelogram, my bad. So that would be the base, and this right here would be the height. So if I wanted to find the area of that whole parallelogram here, I would do base times height. Okay. Now, if you just draw a line here and cut it in half, now this would be half the parallelogram, and that's a triangle. So that's why the area formula for a triangle is just half the area formula for a parallelogram, because a triangle is just half a parallelogram, where this is still the base right here, and that right there is the height. Okay, so in this example, we're going to find the area of an isosceles triangle with a perimeter of 100 and a base measuring 18. So I'll draw an isosceles triangle where the base is 18. I could subtract 18 from the perimeter, which is 100, and I get 82. Then if I divide that by 2, I get 41. So these sides right here are 41 and 41. Now with any isosceles triangle, because they are symmetric, I could split it in half by drawing the height. Okay, so I know these two sides are equal. I know since I drew the height, those angles have to be 90 degrees, and this is a shared segment. So by hypotenuse leg, those two halves of the isosceles triangle have to be congruent. All right, hypotenuse leg. All right, and that's only for right triangles, and it is. So that means by CP/CTC, these two parts of the base have to be 9. Then you could do the Pythagorean theorem to find the height. And a special, often overlooked Pythagorean triple is 9, 40, 41. So if you solve this out, you'd get that the height is 40, and I encourage you to do that. So now that we know the height is 40, we can just do the area is base, so 18 times 40, which is the height, divided by 2. And we get 360 square units. So I just did 18 times 40 over 2, which is 20. So if 18 times 2 is 36, 18 times 20 is 360. Okay, so now we again have an isosceles triangle, but this one, so isosceles, it's equilateral. So we got to find the exact area of an equilateral triangle with perimeter 42. Alright, so if I draw that out, I could find each side length by dividing that by 3, and I get that each side length is 14. Then, just like the isosceles triangle, same idea as the last example, I could split this in half, and I know that side 7 and that side is 7. And since this was equilateral, not only does it create two congruent triangles when you split this in half, it creates two congruent 30, 60, 90 triangles, which would make this height right here 7 root 3. So when I'm finding the area, I could do the base, which is 14, times the height, which is 7 root 3, and then divide by 2. 14 over 2 is 7. 7 times 7 is 49. So my area is 49 root 3 square units. Made up a word. Now in that last example, it was an equilateral triangle. This would be a good time to talk about this formula. And that is special to equilateral triangles. It's x squared, which is the side length, times root 3 divided by 4 gives you the area. So in the previous example, since the perimeter was 42, if we could have just plugged 14 in there and did like 14 squared root 3 over 4, and that would have simplified down to 49 root 3. Now the reason why this works is because no matter what triangle it is, as long as it's an equilateral triangle, you can split this in half, and then your half of that side would be x root 2, and that would be the short leg of this 30, 60, 90 triangle, which means the height would have to be x over 2 times root 3. So when you do the area is equal to the base, which is x, times the height, which is x over 2 root 3, alright, and then all times 1/2, then, and you simplify that, x times x is x squared times root 3, and then over 2 times 1/2 gives us an over 4. Alright, you could just use this formula from now on when you're finding the area of an equilateral triangle, if you want. Or you could split it in half and do it that way. Just two different ways to do it.